Saxon Algebra 2, Lesson 96. Jayla and Lydia, hello. Two topics in this lesson. Part A is about joint and combined variations. Before we dive into this, let's review what we've learned about variations so far. We have learned that there are two types of variations. There are what we call direct variations, and that's the idea that when one thing increases a little bit, the other thing increases also, but by a different amount. We have inverse variations, and that's when one increases, the other goes down. And again, they're not necessarily the same size, okay? So that's the general definition of these. And then we've learned two different methods for solving problems like this. When you see this, you'll remember. The first one is when we use a constant. And let's say that we're comparing peaches and apples. What we said is that the number of peaches will vary directly with the number of apples using a constant to drive the difference between those arrows, right? And we learned that if it's an inverse relationship, then you divide, right? We learned this quite a few lessons ago. And we learned that these are done in two steps. And first we solve for the constant, and then we use the constant with a different set of facts to find either the peaches or the apples, depending on what John wants from us. Then we learned a ratio method. It solves the same kind of question, but instead of using this constant, we can just compare peaches before, peaches after, apples before, apples after. That was hard. That was like a tongue twister. Okay, so the way this formula works is P1 over P2, peaches before, peaches after, equals apples before and apples after. Notice that in both ratios, the 1 is on the top and the 2 is on the bottom, okay? And then we learned that if there's an inverse relationship and we want to use the ratio method, we can do that too. Whoops, that should be a P. This part stays the same, but then we flip for the inverse ratio formula, okay? We've practiced both of those. What we're going to do in this lesson is we're going to combine them in weird and interesting ways. Don't add any formulas. We're just going to work off this basic set of 4 that we already have, but we'll be able to use these to build new formulas to fit our stories. Example 96.1. The number of girls varied inversely as the number of boys and directly as the number of teachers. Okay. So we've got girls, boys, and teachers. We have 3 things that are going on. So that's a little different. First we'll use the constant method. Does John request? He wants us to use both. Well, that seems like overkill. We'll do this one using the constant method, and then the next problem we'll use the ratio method, just to show you that they both work. Okay, the number of girls, we're going to build our own formula using these as reference points, varies inversely as the number of boys. Okay, so inversely means boys goes on the bottom. The constant always stays up top. And directly as the number of teachers. Okay, so a direct variation, it needs to be on the same level. So this is our formula that we built. The number of girls varies inversely as the number of boys and directly as the number of teachers. Okay, we can do that. So now we have our first scenario, G, T, B. We're going to need this information so we can solve for K. When there were 50 girls, there were 20 teachers and 10 boys. Okay, I'm going to stop right there this is our first step. We're going to use this to solve for k. So 50 equals k times 20 divided by 10. Yes? Okay, good. Let's do this. Let's multiply by the reciprocal to make all this cancel, and then we have to do it over here as well. Okay, this becomes 500 on top. Yes. And 500 on top, so then I'll do it here. 500 divided by 20 is the same as 50 divided by 2, so k equals 25. That is exactly what we set out to do in step number 1, is solve for k. Check here and make sure you got the right constant before you go on with the problem. And yes, that's correct in this problem. Okay, now we use that in our second scenario. And again, we use our 3 variables. We know we're only going to get 2 of these 3 because that will be our job, is to solve for the third. Okay, how many boys were there? That's our mystery. When there were 10 girls and 100 teachers. All right, so now we can set this up plugging in 25 for k, and we use this formula still. Whoops, drew a line through the B. Girls, I'm going to do buckets because we have a lot of things flying around here. The number of girls is 10. The constant is 25. The number of teachers is 100. And the number of boys is B. Okay? I think the first thing I'll do is cross multiply, and I'll get 10b equals, and I'm not going to multiply that, 25 times 100, and then I'm going to divide both sides by 10. And if I divide top and bottom by 10, I'll get my final answer. This cancels, and the 10s cancel top and bottom, so 25 times 10, the number of boys equals 250. Sorry, that's a little squish. I hope you can see that. It's in the book, and John did it pretty much like I did, so you can look on page 399 if you can't make out my numbers or think that's annoying. Okay, so we took the direct and inverse formulas and we mushed them together to fit our story. Let's try another one. And this is the last of this style of problem. Example 96.2. And this one we said we're going to use the ratio method. Again, John says to use both. If he tells you that in the homework, I guess you better do it that way in the homework, but, you know, I write my own rules, so sorry. Okay, strawberries varied jointly as plums and tomatoes. Okay, so strawberries, plums, and tomatoes. And they varied jointly. That means that everyone's moving in the same direction. So we're doing ratio method, so strawberries 1 over strawberries 2 equals, what did we say, plums 1 over plums 2 times tomatoes 1 over tomatoes 2. Everybody's moving in the same direction. That's what varied jointly means. That's the word. And so we have this kind of relationship. They might not all be going up by the same amount, but they're all moving in the same direction. So we have all the 1s on top and all the 2s on the bottom. Yay! All right, now we need some numbers. And let's see, if 500 strawberries went with 4 plums and 25 tomatoes, how many plums? Let's just fill in. I don't want to keep reading that. That will make you crazy and me crazy. All right, 500 strawberries goes with 4 plums and 25 tomatoes. Notice they're all across in the numerator. how many plums, so P2 is what we're solving for, would go with 40 strawberries and 2 tomatoes. So I'm just plugging in. Now, this is what I was thinking before when I was sort of pausing. This would be a really nice time of up here. We could have solved this for the variable we want, because we've got this P2 buried down here. But we're just going to tough it out and see what happens. So the first thing that we're going to do is cross multiply. Okay, and get our P out of the basement. That sounds weird. You know what I mean. Okay, so we have 500 times 2 times P2. See, I'm not multiplying them because I know we're going to be able to cancel. And then 40 times 4 times 25. Okay? So that is where we're at so far. By cross multiplying, we got that. Now, I want this to be P2 by itself. So I'm going to divide by 1,000 because I know that equals 1,000. Okay? So this is all gone. P2 equals, now, this is what my brain is doing. I'm looking for things I can cancel. I know that 4 times 25 is 100 because 4 quarters, right? So that tells me that 40 times 25 should be 1,000, right? Because it's 10 times bigger than 4 times 25. So this, and this all cancel. You can write that out and test it if you are not quite sure, but 40 times 25 equals 1,000. 1,000 on the top cancels 1,000 on the bottom, and that means that the number of plums that we have in the end is 4. Pretty cool, right? I like that. So these problems are not difficult, they're tricky, and the secret is to make sure that you have these formulas clear in your mind and then combine them as the story dictates. Okay? Now we get to do part B, which is called More on Irrational Roots. I'm going to flip. What the heck? You only live once. Let's get a fresh page. Okay. B. Irrational roots. Now, a couple lessons ago, we were solving a system of equations. It looked something like this one. And my marker's running dry. It's starting to have that scratchy feeling. Okay, we had a system of equations. It's non-linear. We can see this is a line, but this isn't. This one we'll call A. This one we'll call B. And we started solving this. So we're going to carry on just like we did last time. And what we learned is that we can't eliminate because the forms of these are so different. And we learned that there's no way to get around having a fraction. So this we can change to either x equals 6 over y, or we could write y equals 6 over x. It doesn't really matter which way you do it because you have drama either way with that fraction. We will use this method today, or this value to substitute. So now we're going to substitute that into A. So we're substituting B into A. We're just using this weird form of B, right? We just changed it around. So now here's A. It's x, but we changed x into 6 over y. So I'm going to put parentheses around it so you know that that's how we changed it. 6 over y minus 2y equals 3. Okay? All right, that's correct, but I'm still unhappy. I don't like having this y in the denominator. So, since this is an equation, we can eliminate that denominator by multiplying every term by y. We have to multiply. If we're going to do 1, we have to do everything. This cancels just the way I want, but now we have 6 minus 2y squared equals 3y. Okay. Better. I like not having the denominators, but now we have what looks like it's going to turn out to be a quadratic equation. So I'm going to shove everybody to the right swim. Come on, I don't need to be violent. Cancel, cancel, and we're going to get, I'm going to write it over here, 2y squared plus 3y minus 6 equals 0. I'm going to change to a new marker while you contemplate the glory of that. Okay, I'm back. Now, last time when we got to something that was so cute that we could factor it by inspection. John saved us a lot of drama and hard work by giving us a quadratic equation at this point that we could factor with our eyeballs. This time we have no such luck. So we have to quadraticize it. I'm asking you in my head to give me this. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Notice that this time, because our quadratic equation is stated in terms of y, we're saying y equals, not x equals. That's going to be a little bit of work for us later on. All right, a, b, c, a is 2, b is 3, c is minus 6. All right, so I'm going to make my buckets. I'm going to have to flip the page in the middle of this, and I'm super sad about it. All over 2a. Okay. B goes here and here. A goes here and here. C goes there only. Okay. So this will be minus 3. And again, I'm going to write the y equals because I don't want to forget that. This is 9. This becomes plus. Let's see, how can we combine this so we can do it in our heads? 4 times 2 is 8. 8 times 6 is 48. So that would be 57, and this is 4 on the bottom. So it's going to be minus 3 plus or minus the square root of 57 over 4. Let's see if I can remember this. Minus 3 plus or minus the square root of 57 over 4, and that's y equals. I'm going to peek back one more time. Guess I could look in the book too. Minus 3, square root of 57, 4. Yes, okay. So we have gotten a value, technically 2 values, for y, because that's plus and minus. Now what we have to do is solve this for x. And I'm going back to my original equations. I'll show you. Here are our original equations. We're going to want to take this one, this formula, because this one's got division in it. We don't want to mess with that now. Multiplication or division, depending on which form we use. We'd rather do this plus or minus 1. So x minus 2y equals 3. Whoops, flipped the wrong way. X minus 2y equals 3. We're going to swim this 2y over. X equals 2y plus 3. We're going to use this and plug in these y values in order to calculate our x's. Okay, so this is what we're going to use for our plug-in. This splits out into 2 tracks now, right? Because we want to handle each, the plus and the minus, differently. Minus 3 plus square root of 57. And I'm trying to decide. Let's make these separate fractions. We could write one big line and put them both over 4. I'm going to try splitting them. I think that will be a little bit easier to make sense of. And then this will be minus 3 over 4 plus square root of 57 over 4. Okay, so these are our 2 different values for y. And now we're going to plug them into this to calculate our x. So hold on to your hat. 2 times this whole thing goes in here, minus 3 over 4 plus square root of 57 over 4. And then we're adding 3, but I want to add 3 as a a number with 4 in the denominator. So I changed 3 into 12 over 4. That way I'll be able to combine this. I don't know if I need to do that, but I'm going to leave it like that. So this then becomes I'm going to multiply it out. There's 2 ways I could do this, but I'm going to do it the longer way. Okay, so I distributed the 2. 2 times minus 3 is minus 6. 2 times square root of 57. And then this comes straight down. Now I can combine this and this. So I'm going to have positive 6 over 4 plus 2 times the square root of 57 over 4. Okay, I added these two to get a positive 6. And now I can simplify this to 3 over 2 and this to square root of 57 over 2. I can reduce that, right? So that's what I did on both of these. So this is now the x value that goes with this y value. So look, I'm going to write them. So I'm saying that this is one of the points where those two original systems of equations, that original system of equations, this is one of their points of intersection. Positive 3 over 2 plus square root of 57 over 2, comma, minus 3/4 plus square root of 57 over 4. Okay, so this is correct. But we're not done because now we have to do this side. And I'm going to draw a line. Got a little encroachment here, so I'm going to have to work around that. Okay, so now we're going to do the very same thing, but this time we have, oh, there should be a negative sign here, not a positive. Abby, did you notice? That it's been driving you crazy the whole time. But I found it. Okay, so now x equals, and we're using this formula, 2 times this whole wonky y value, minus 3 over 4 minus square root of 57 over 4, plus, this time I'm just going to leave it as 3 for now. We'll put a denominator on it later. This time, before I distribute, I'm going to say, wait a minute, I can cancel this 2 against this 2, and this 2 against the 4 and the 4, and I am left with halves on the bottom. So I cancel rather than distribute and then reduce. I just canceled right here, and I can do that because I have 4s on both parts. So I'm canceling both parts of that. That makes it fair. Okay, so now I've got minus 3 over 2 minus square root of 57 over 2, and now I'm going to change this to 6 over 2. That is still equal to 3. But I waited to fix my denominators, and then I used the denominator that matches to these guys. Just like over here, I can combine the two regular fractions. I can't do anything with that square root of 57. That's a mess. I can't touch that. But I can combine these guys, and I get positive 3 over 2, right? Because minus 3 over 2 plus 6 over 2 gives me positive 3 over 2 minus square root of 57 over 2. That's our new x value. So I put a comma, I put parentheses on this, right? And my y value was minus 3 over 4 minus square root of 57 over 4. This is my second pair of points. Let me double check in the book. Positive 3 over 2 minus square root of 57 over 2, comma, minus 3 over 4 minus square root of 57 over 4. Gracie's barking. She's got things to say about this. Those are the 2 points where our original system of equations intersected. They are scary, irrational points, but they are correct. If you understand this even a little bit, pat yourself on the back right now. You're really smart, and we'll be doing this for a while. It will make, I know it's a pain. It's a lot of work, but in the end, feel very proud when you get all of this right, because it's fabulous. Okay, that's lesson 96. Thank you, ladies. I will see you soon.